Okay, hello class. So our presentation today is about valence electrons, um, electron configuration, orbital notation, and noble gas notation, or orbital diagram and noble gas notation. But before we go to that, since we are talking about electrons, I want you to know what are valence electrons. Valence electrons, the knowledge of this will be later on also be used when we get to bonding. But valence electrons are the electrons that you can find on the outermost part of the atom. Like, for instance, this is a carbon atom. So you have four electrons on the outermost energy level. Therefore, you can say, oh, this atom has four valence electrons. It has six electrons total, but I'm only looking for valence electrons, which are the electrons found on the outermost energy level. So that's how you will know the valence electrons. By the way, atoms needed to be filled in order for them to become stable. That's why they keep on bonding with each other to form one or more, to form a compound, or one or two of them combine to form a mixture or whatnot. But so valence electrons again, this is four valence electrons for carbon. Okay, what about this one? Okay, so you have the nucleus, you have the protons and neutrons inside. Um, let's just assume that some of the protons and neutrons can't be seen because they're on the other side. You cannot see it, but we can clearly see the electrons. The total number of electrons are 18 if you count it. So 2 plus 8, 10 plus 8, 18. So the last energy level has 8 electrons. Therefore, this atom is or has 8 valence electrons. So I would say, what elements is this? 18. Let's find out in the periodic table. So 18 electrons, that's argon. Okay, so that's the atom of argon, and it has 8 valence electrons. So now this is our periodic table, right? So there's actually a what do you call that? There's an order of valence electrons according to the periodic table. You can predict the valence electrons of groups based on their arrangement. We've learned about periodic trend, and this is one of them. Okay, so I have here a chart which is pretty similar to your periodic table. Okay, so this group here, all of them here have one valence electron. Okay, the next group has two valence electrons. So it's just in increasing order. The middle part is blank because there's no valence electron. I mean, they have more than one valence electron, so we're not gonna assign them a single valence electron. So this group is 3, 4, 5, 6, 7. This one's 2 because that's helium. Helium has only 4 electrons. So on the outermost has 2 valence electrons, and of course 8 for the rest of them. Okay, same thing with this one. They have more than one valence electron, so we disregard. Just focus on the ones with numbers. Okay, so any questions? Let's go to electron configuration. So what is electron configuration? Okay, so there are sub-level blocks, and we call them the SPDF. Okay, so groups 1 to 2 are called the S level. Groups 3 to or groups 13 to 18 are called the P level. Groups 3 to 12, which are 3B and 2B, that's the D level, and then the lanthanides and actinides at the bottom are called F level. So here is a periodic table. So again, there's a S, and then there's P, there's D, and there's F. How does it look like? Like this. So S, this is P here, this is D, and this is F. So these are the sublevel blocks. Take note, when you find an element in that particular block, side of the periodic table, like here, the last uh, the last letter of its configuration ends with the S. Okay, if it's here, it ends with D, and here P, and here F. Okay, so let's start. How do we write electron configuration? Um, I'll just teach you this part. This one is a little bit complicated, but this one's easier. So this is the arrangement. 1s, you just follow that. 2s, 2p, 3s, 3p, 4s, 3d, 4p. Just keep following that line, and then you will find a sequence. I don't know if it's here, but the s can fill up to two electrons, and only up to two. So please take note. S is only up to 2, P is only up to 6, D is only up to 10, F is up to 14. So take note of those numbers again. S is 2, that's the maximum it can hold. P is 6, D is 10, F is 14. So here you go. If you write it in order, this is the order. So it's going to be 1s, and then the 2 would be its exponent. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and so on and so forth. What are these numbers? So the exponents are the ones you're going to count later on. You're going to count how many electrons are in there, and then you're going to write the exponent and match the number. Let's say 10 electrons. Make sure the exponent is equivalent to 10. So I'm going to teach you that. For example, this one. Use your periodic table, don't forget, okay? Write the electron configuration for silicon. So you go back to your periodic table and look at, okay, let's go back to your periodic table. Silicon, here, here. So that's your silicon, has 14 electrons. So what you're going to do is you're going to count. Basically, this is counting. So like this, you follow this one, okay? Make sure it's 14. So 1s2, that's 2. 2s2, that's 4. 2p6, that's 10. 3s2, that's 12. 3p2, because there's only 14, and the maximum p can hold is up to 6, but only 2, because if you add all together the exponents, it's going to be 14. So this is the electron configuration of the element silicon. Okay, how about manganese? Okay, let's write electron configuration of manganese. So let's go back to the table. Manganese, okay, it's right here, 25. Okay, so 25 electrons here. So you're gonna write down the same thing, follow the order. If I were you, I'm gonna write it down in my notebook so it's accessible, because you will need that sequence. And it will allow you to look at that sequence, okay? 1s2, oops, sorry, 2s2, 2p6, that's already 10, 6, 2, 2, 10, 3s2, 3p6, 4s2, 3d5. So let's count. So 10, 12 plus 6, 18, 20, 25. D can hold up to 10, but only 5 electrons for D, because of it's only 25. If you put more than that, it's not going to be manganese anymore. Okay, so for the 4s block, these are examples, and it's electron configuration. This is the noble gas notation, I'll explain later, but this is the electron configuration. These are the elements in the 3D block and the electron configuration. They're small, but you can write it down if you have the sequence. The electron configuration of P block. Okay, so learning check. You can do it on your own, at your own time. But write down the electron configuration of Zn, Sr, and I. Okay, so pause this if you want to answer it, and then you play it when you want to know the answer. Okay, so pause. Okay, so when you're done answering, here are the answers. Check your work for zinc, for strontium, and for iodine. Okay, all right. So I hope no questions for that. Let's go to orbital. Okay, orbital diagram. So orbital diagram, you use boxes and you use arrows. So we still use the same thing. We use the electric configuration as a guide to it, like 1s, 2s, 2p. But keep in mind, S can fill up to 2, so there's only one box. And each box can fill up 2 arrows opposite top and bottom. Okay, when you go to P, P can have 3 boxes because it can fill up 6, right? So top, bottom, top, bottom, top, bottom. Okay, and then D can fill up to 5 boxes with 2 arrows per box, so that makes 10. And then F, of course, is 7 boxes times 2, that's going to be 14. So what are the rules in writing orbital diagram? So you also need to know the number of electrons. Every time you do this, you need to know the number of electrons. And it's good if you know the electron configuration first, and then you do the orbital diagram. So here we go. Okay, so how are electrons in their orbitals like an apartment house? So let's have an analogy. Different floors in the apartment represent different energy levels or shells. Each room and each floor in the apartment house corresponds to an orbital. So if there are rules, the first rule is Aufbau principle. So this one, it is related to when there's an apartment. The rule for the apartment would be from the bottom up. So the rooms in the ground floor should be filled up first before you can go to the next floor. So you have to fill all the rooms before you can get to the next floor. Like as you get higher, the order might change a bit, but just understand the basic. Start from the ground floor and go to second floor and all the way to the next. So it's like an order. So that's Aufbau principle. Okay. Pauli exclusion principle. The electrons come in two varieties based on the direction they're spinning. So there's up down arrows. The reason why they're opposite because they're spinning in different directions. So that would be just an analogy, opposite gender only in one room. So like when two people are placed in a room, only two. Remember the maximum in one room. There they have to have opposite genders. That's the rule. No men may room together, and no women may room together. Okay, so that's just to give an example of how it looks like. Okay, and then the last one is Hund's rule. Hund's rule's electron must be placed into the orbitals in such a way that no pairs are put together unless absolutely necessary. That is, single electrons must be placed into boxes first and then paired up if necessary. Like it doesn't mean if it's just one electron, then be it. It doesn't have to have a partner. Like if especially if it's at the end already. But so for the apartment, singles first. The owner of the building wants to have the tenants spread out as much as possible. For that reason, singles are placed in rooms before couples. If couples must be placed into a room, then all the other rooms on that floor must already have a single in them. Okay, so single, single, single. But then they have to fill it in first. Okay, I don't know if you understand, but I'm gonna show you how it looks like. So, lithium, for example. Okay, lithium has 3 electrons. So when you write down its electron configuration, it's 1s2, 2s1. So top, bottom. Make sure you do top first, bottom. Okay, that's 2 plus 1, 3. It has to be top. This is the singles only. Like single doesn't matter. Okay, you don't have to fill it up with another one because there's only 3 electrons. Okay, so other elements have nitrogen. So nitrogen has 7 electrons. So top, bottom, 1s2, top, bottom, 2s2, and then 2p3, single, single, single. Okay, so that's what it means. Is for the p's, you do this the top, top, top first, and then later on you can do the bottom, bottom. If you notice here, down, down, down. Okay, so again, up, up, up first, and then you fill in the second ones. Like this one filled in only one because it's only 8. This one only filled in the 2 downs because there's only 9. But this one's filled because this is 10. Okay, so let's see if you know how. Okay, write the orbital diagram for nitrogen, calcium, and magnesium. So pause this, and then if you have the answer, you can play the video. All right, I'm going to reveal the answer or the answers. So nitrogen, that's the orbital diagram. This is how it looks like. So it really helps if you have this on top so that it can help, it can guide you. Okay, oxygen, this is how it looks like. And magnesium, this is how it looks like. So you have a 3s here at the end. Okay, so so like I said, you read it as 1s2, 2s2, 2p2, and all that earlier. I've been doing that, so just follow that. Okay, so this is orbital diagram, electron configuration. So now let's go to noble gas notation. Noble gas notation is we use the noble gas group 18 first with a bracket. It represents the number of electrons on that particular, when like this one's helium. Helium has what, two or four electrons. So instead of writing, or only two, instead of writing the whole thing, so you shortcut, there's an abbreviation, so you put a bracket on helium. So removing this one here, removed, and the rest of it you just write down. Okay, I'll explain more. All right, for example, lithium. Lithium has this 3 electrons, configuration of 1s2, 2s1. How do you write? It's abbreviated. So you take out the closest noble gas to it, which is before it, not after, before that element. What is the noble gas? So before lithium, okay, lithium's here. Before lithium, you have to look on the other side. That's helium. So helium, put a bracket, and then helium is 2. And then you remove this one, so that's the helium. And then 2s1, just copy the remaining. Okay? And the rest of them, they follow the same thing. They're all helium. But here it's different. Neon. Okay, so Na, let's see. Okay, yeah, I'm gonna use Al. Al, aluminum is 13. So its orbital diagram is, or no, its electron configuration is this. Orbital diagram, they just shortcut it, but just focus on this one. This is the electron configuration, so 10, 12, 13. So instead of writing the full electron configuration, noble gas notation, or abbreviated electron configuration, allows you to just shortcut into a noble gas. So aluminum, right? Let's go back to this. Aluminum's here. We don't look at here. No, you look at before this aluminum, way back. Like, okay, so it's neon, right? Neon first and then aluminum. So neon, aluminum. So you're gonna put the bracket. Neon is 10. So remove the 10 first. So where's aluminum? So this is 2 plus 2, 4 plus 6, 10. So remove this all the way to 6. And then the remaining, just copy 3s2, 3p1. That's it. All right, so the learning check. The correct electron configuration for nitrogen is, you choose your answer. Correct electron configuration for oxygen is, correct electron configuration for calcium is, so pause. And if you're ready, I'm going to give the answer so that you will know if it's correct. Okay, there's your answer. 3, 2, and 2. All right, learning check. Write the noble gas notation of each. Again, you are already given the electron configuration. You just need to write the noble gas notation. Please pause and answer. And then when you're done, okay, here are the answers. Okay, so that's it. I hope that you have learned. Well, this is also another learning check that you might want to do. Just pause it, okay, and do it. And then, of course, it's not mandatory, but I know that it's going to help you. So if not, it's up to you if you will do it. But I'm suggesting, I highly recommend that you do it so you will learn and you will understand it, okay? All right, your answers. Yeah, I think I'm done. That's pretty much it. I hope that you understand it, and I hope that um, this will be a smooth lesson. Just let me know if you have questions. Thank you.